Concept check 3.7. Suppose an electric potential is described by V of xyz equals negative 5x squared plus y plus z in volts. Which of the following expression describes the associated electric field in units of volts per meter? So here I have the three-dimensional potential function V of x, y, z to be equal to minus 5x squared plus y plus z. And we need to find which of these expressions for electric field corresponds to this potential. We know we can find electric field by taking negative derivative of the potential function. So I will find the x, y, and z component of electric field by taking partial derivatives of V with respect to x, y, and z. So let's start with the x component. I will write Ex to be equal to negative derivative of V with respect to x. So I get negative derivative of minus 5x squared plus y plus z dx. The minus and minus cancel and you get Ex to be equal to derivative of 5x squared is 10x. Now when you're taking derivative with respect to x, any term which is not x is considered to be a constant. So here y and z will be treated as constant. And since they don't have any term with x, we know that derivative of such constant is equal to 0. So Ex will just be equal to 10x. We do the same thing for Ey. I will write Ey to be equal to negative derivative of V with respect to y. So substitute for V, negative derivative of minus 5x squared plus y plus z over dy. Again, since you're taking derivative with respect to y, any term which is not y will be treated as constant. So minus minus here becomes plus. The first term does not contain y, and since we are taking derivative with respect to y, x will be considered constant here, and derivative of a constant is 0. So the first term will be 0. Second term is just y, so derivative of y is 1. Third term again does not contain any y, and z is treated as a constant, so derivative of a constant will be 0. So Ey is just 1. Let's do the same thing to find Ez, which will be equal to negative derivative of V with respect to z, which is minus negative 5x squared plus y plus z. Again, since we are taking derivative with respect to z, x and y will be considered as constant. Both the first and the second term does not contain any z, so they are treated as a constant and derivative of a constant is 0. Only the last term contains z and derivative of just z is 1 again. Minus and minus here will give you plus. Once I found Ex, Ey, and Ez, now I will write them in their vector format. We write E to be equal to Ax x cap plus Ey y cap plus Ez z cap. Now substitute. X component is 10x x cap. Y component is just 1, so just y cap. Z component is also 1, so z cap. So this is my value of E that is associated to the given potential, which is option